Welcome. So now we're going to review graphing sine and cosine functions. And we're going to start at the beginning to make sure that everything is clear for all the students. So the graph of sine and cosine functions are made by evaluating each function at the special angles on the unit circle. Now some are easier to graph than others, and those are the ones we choose to graph. Right? We don't have to graph every single value from a table of values. We choose 5 values, and these are the 5 values that are easy to graph. I will show you a few more values just so you can see that all these values come from the special angles. Those special angles are either multiples of 30, multiples of 60, multiples of 45, or the quad angles, which are multiples of 45, right? Because they're 0, 90, 180, 270, and 360. Now, we're not going to be graphing in degrees. We're going to be graphing in radians. All right, so instead, they're going to be, those special angles are going to be multiples of pi 6, pi thirds, pi fourths, or pi halves. The input of the function, the x values, are the angles, and we're going to work only in radians, right, as we're going around the circle. The output is the value of the function for that angle. We can unwrap these values from the unit circle and place them on the coordinate plane. And that's what we're going to do. Let's start off with the easy values, and then we'll work our way to some other values as well. All right, so the x values are the angle measures. The y values, in this case since we're graphing f of x equals sine x, the y values are the sine ratios. Notice that it says, and I believe this is in your notes, you'll write in anything that's not already written in. Notice that it says y values on the unit circle, and you might be thinking, why just the y values? Well, remember that sine is opposite over hypotenuse. On the coordinate plane, the opposite is the y, and since our radius is being held, here's our radius, is being held to 1, right? If you divide anything by 1, it's just going to stay exactly the same. So the sine ratios are the y values on the unit circle. Right? So now let's start off with the easy values. Probably the easiest value is right here. Right? We haven't gone anywhere. Right? So the angle measure here, theta, our x. Actually, we usually use theta for angles. I'm just going to put x so that you remember. So our x values for our graph is just 0. This particular point is the point 1, 0. But remember that sine uses the y values. So this is the point 0, 0. So I'm going to graph that 0, 0. I'll come back and graph some other values. But let's go over to right here. All right, so now I want this angle right here. All right, so that angle measure, our x for our graph, is going to be pi halves. That particular point, right, so we're moving a 1 unit radius, right? So now our y, so notice we're right on the x-axis, or right on the y-axis. So x here is 0. Since the radius is 1, y is 1. So now this point is going to be the point pi halves 1. And before I can go any further, 0, 0 is no problem to graph, but I'm going to need to put some more values on my graph here. How about we make, well, that'll fit pretty nicely. All right, so the x values are the radians. All right, so, and the y values are what we get when we evaluate sine. So this is, let's label this. So this is in just the integers, and our x is in radians. All right, so now we have the point pi halves 1. We can graph that. Maybe I'll stick to the same colors. There we go. There is the point pi halves 1. So we graph the point. Actually, here, maybe since I've already got blue on here, I'll use red. So we graph the point 0, 0. We graph the point pi halves 1. Right? What if we come over here? Right? So in radians, this is pi. That's going to be our x. Oops. And it all stuck together, and I can't move it over. Right, so this, we've gone pi now. All right, and so that's the point. And so now x is -1. Sine is 0. So the point that we're going to graph on our graph is the point pi 0. So that's the point. Where can I squeeze it in? I guess right above pi 0. All right, so now we're going to go 3/4 of the way around the circle. All right, so that is 3 pi halves. That point there, right, so we're on the y-axis, x is 0, and y is -1. I don't think I can move that. Oh, but I can't move that figure thing down, I don't think. No. Let me see if I can write that where you can actually read it. How about I put it over here? All right, so that's 0, -1. All right, so sine uses the, oh, and let me fix my 3 pi halves. That looks like 3 times pi halves, not 3 pi in the numerator and 2 in the denominator. All right, there we go. All right, so our x value is going to be the 3 pi halves. Our y value will be the y value for the point, -1. So now we can graph the point 3 pi halves -1. And that's going to go in the middle of my 2 there. So this is the point 3 pi halves -1. And then if we were to go all the way around the circle, okay, we've gone 360 degrees. That's also 2 pi. So now 2 pi is going to be the x. And that point is still 1, 0. 0 is going to be the y. Now we could keep going around the circle, and in reality, the graph does. This graph continues going in the positive direction, the negative direction. It just never, ever stops. However, at some point, we have to stop graphing. So otherwise, we'd just be doing this forever. For the rest of your life, you'd be graphing this graph, because it goes on infinitely. And actually, before I connect, I want to talk about some other points. So it does continue in both directions, but we're just going to graph one period. We could possibly put some other points on here. These are the nice ones to graph, right? They're nice because we can make the radian measures go up by something that's friendly for us. And they have nice integer values, so this wasn't too bad, right, for our graph. There are some other points we could graph. In reality, we're not going to graph them, except for on this one graph. Right? Because I want you to understand where all the values come from. So all the values of sine are represented. The ones that are the friendliest, the ones that we can actually calculate out with no problem, are the special angles. Right? So let's say, oops, is that guy going to go in there? And my pen decided not to write. Well, just, oh, there it is. And actually, I think I'm going to make this angle a little smaller, otherwise it won't look very realistic. Oh, come on. Oh, no. Come on, come on. Come on, little blue line. Here, we'll just do this. Cut. Cut. No, not copy. Cut. Did it cut? Oh, I don't think so. Go away, little blue line. Okay, I'm going to make that a little shorter. I'm actually going to make it go here, just so it looks a little more realistic. And I'm going to tell you in radians that value, let's see if I can squeeze this in, is pi 6. All right, so pi 6 is the same as 30 degrees. And we know that's the 30, 60, 90 right triangle. I'm not going to label all of the sides. I'm going to just label the sides that, that sine will use, which is the opposite and the hypotenuse. Now remember, this is a radius of a circle, and we have limited it to 1. So normally, right, if we're dealing with the 30, 60, 90, or pi 6, pi thirds, pi half angle, opposite 30 degrees, or pi 6, the short leg, is 1. Opposite 60 degrees, or pi thirds, or the long leg, is the square root of 3. And the hypotenuse is 2. The 2 that sine would use, of course, is the opposite and the hypotenuse. But we have a problem because I said the hypotenuse can only be 1. That means we divided it by 2. So if we divide both of these by 2, it means now that opposite side is going to be 1/2. And 1/2 divided by 1 is still 1/2. So if I wanted to use this point here, I would have the point pi 6, 1/2. All right, so let's see. Here's pi, I know where pi fourths is, so pi 6, all right, well let's see. Pi fourths would be 45, that'd be 30, about right here. All right, so we have a point roughly, oops, a little too high there. If I make the dot big enough, I'm sure to hit in the right spot. We have a point over here that we could use if we wanted to. Pi 6, 1/2. Now that's not so bad on the y, but it doesn't really go well with my x's. I had to kind of estimate there where pi 6 is located. Pi fourths would be right here, so it's not as big as pi fourths. All right, so but we could use that point. We could also use this angle right here. What if I tell you that angle, I'm telling you that angle is pi fourths. All right, so now if we think about pi fourths, that's the same as 45 degrees. This is the 45, 45, 90 right triangle. Both the sides are 1. The hypotenuse is the square root of 2. Oh, but I said we had to limit it, that the radius is 1. Well, that means I'm going to have to divide by the square root of 2. We should really rationalize that. Can I fit it in? Yeah, there we go. So now this point is going to be, so the angle was pi fourths. This point here is the point, Well, I'll tell you, cosine and sine are exactly the same, right, on the 45-degree angle. So actually, we'll leave off. So over here, I didn't include, so we won't talk at all about the x value, the point on the grid. We'll just talk about what it's going to be over here, because we're not really worried about cosine. We'll deal with cosine later. But for the graph over there, the x value was pi-fourths. On this circle, the x value is really the square root of 2 over 2, the cosine value. But when we're graphing sine over here, going around the unit circle, we don't care anything about cosine. So we only care about the angle measure and the value of sine. That's it. Cosine has its own graph. So when, on our unit circle here, when the angle was pi-fourths, sine was the square root of 2 over 2. Now you see, that one's not so nice to graph. I don't really want to graph that one. I don't mind the pi-fourths. I know where that goes. But square root of 2 over 2, I can kind of estimate it based on how the graph goes. But I don't really know I don't know that value. I could get a decimal equivalent. But that one's not so nice to graph. So there are lots of angles here that are not so nice to graph. And so we usually skip those angles and just graph the ones that are nice to graph. Right? We know our graph will go through all the points. And matter of fact, as we're going around the angle here, right? And for some reason, all of my fraction bars are gone. All right, so we saw the point pi-6 1/2. I could have also graphed, but it's a little busy in there. Pi-thirds, right? So that would just be this triangle. Imagine that's a triangle. Ooh, I don't have that good imagination. All right, so if this is pi-thirds, opposite it, that's 60 degrees. Opposite would be the square root of 3. The adjacent side would be 1, and the hypotenuse would be 2. But if our hypotenuse is limited and it has to be 1, we'd have to divide by 2 again. And that would give you our value of the square root of 3 over 2. And we could graph every one of these special right triangles in the circle, because those give us the values for the y values for our graph. But look they're not very nice to graph. The 1/2 is okay, except I have pi-6 to go with it, which really doesn't work with our graph. 5 pi-6 is okay too. The y value, 1/2, except it's not really that nice on the x, because like I said, 5 pi-6 doesn't really go with the graph. So 5 pi-6 would be about here. Right? And if we were on the unit circle, for looking at it, 5 pi-6 is over here. Right? Because we go all the way to the green line, we're at pi-6. This is 5 pi-6. But inside that triangle, we know the reference angle over here would be pi minus 5 pi-6. So that's pi-6. Opposite pi-6, that's a 30 degree, it's the same as 30 degrees, is the 1. This would be the square root of 3, and this would be 2. Oh, but I said we have to limit our radius, because our radius is only 1. So if our radius can only be 1, the short leg can only be a half, because the hypotenuse is twice the short leg, right, in the 30, 60, 90 triangle. All right, so now 5 pi-6 is positive, right, because the y value is positive. If we were 1/6 below the x-axis, oops, I wanted to just get that line in the right, here, just do it again. Poor little fraction bar. Maybe I should orient the board some of these days. Good enough, good enough. All right, so if we were below the x-axis, then the values are all negative, because that's where y is negative. All right? And so here are all the special right. I'm not going to go through every single one of them on the graph here. Here are some of the special right angles as we go around the circle one time. And notice the ones that are the nicest to graph are those ones, actually I'll circle the angle too, are those ones that are the quad angles. And that's why we limit ourselves to the quad angles. It's enough, right? These 5 points are enough for us to graph. We don't have to have, 100 points to graph sine. If we connect the dots, we see there's our graph of sine, and it's going to continue in both directions. So I wanted to make sure it was clear where these values come from. Let's do the same thing with cosine, and then we'll stop. Again, the x values are the angle measures. Now the y's are the cosine values. So whereas sine used the y values, whereas sine used the y values on the unit circle, cosine uses the x values on the unit circle. All right. So if we're going to be at 0 degrees, that's going to be our x. X will be 0. And that's the point 1, 0. So the point that we would graph, oh, and again I have to do this. So this is 0 and pi halves and pi and 3 pi halves and 2 pi. Yeah. All right, so the point that we would graph would be the point 0, 1. And we should probably label the y's too. Right, so now if we go pi halves, that's the point 0, 1. Our x value for our graph is going to be pi halves. The y value for our graph will be the x value from that point, or 0. So now we have the point, oh, and I forgot to label. So this was the point pi halves 0. And I noticed actually on this graph over here, we had one more point, and I didn't label that one. That doesn't really fit in there. I'm okay not labeling. I can't fit the numbers in there. All right, so now we graphed the point pi halves 0. If we go halfway, x is pi. This is the point -1, 0. All right, so now we can graph that one. And remember, the x is pi. We use the x value only from that point. So our point here is the point pi -1. If we continue all 3/4 the way, this is going to be 3 pi halves, that will be our x value. This point is the point 0, -1. We use the x values for cosine, so that would be 3 pi halves 0. And if we go all the way around, we're back at 2 pi, and we're back at 1 because we use the x value. My pen's gonna graph purple if I don't put it back. All right. Again, we could get some extra values, right, if we wanted. All right. So, for instance, what if this angle here is pi thirds? Remember that cosine is adjacent over hypotenuse. Let me draw this over here. So if this is pi thirds, the adjacent side is going to be the side that's opposite the pi 6, so that's going to be 1. the hypotenuse would be 2. And then the opposite side, which we don't need, is to be the square root of 3. But remember, I said that the radius is limited to 1, right? Because we have a radius of 1 going around. So we'll have to divide all of those by 2. So this would be the point. Now I'm just going to write down the values for the cosine graph over here, right? Because we don't really care about what sine is. Right? So the x value is our angle measure, which is pi thirds. The value of cosine is 1/2 there. So we could graph the point pi thirds 1/2. And I'm going to have the exact same problem. Well, it's bigger than 1/4, so it's maybe right about there. I got to estimate it. Right? So maybe we want to go, maybe we'll graph 1 in the second quadrant. All right, so what if we go right here? All right, and what if this is, all right, so we got pi fourths, pi halves. This is going to be 3 pi fourths. All right, now that's just the (45, 45, 90) right triangle. So it's going to be 1 square root of 2. Oh, but remember, I'm going to have to divide by the square root of 2 because, well, our radius is limited to 1. And we better rationalize. So now we have this point here, square root of 2 over 2. And, well, that was just as lousy as the one we had on the sine graph, right? So 3 pi fourths is no problem. But I don't want to graph square root of 2 over 2 very much. And that's not just positive square root of 2 over 2, right? Because, remember, cosine uses the x values. The x values are negative in the second quadrant. So this would be the point negative square root of 2 over 2. And we can see that in our graph. If I go over to 3 pi fourths, oh, we can't see it in this graph because 3 pi fourths is not in this graph. They just did the thirds and the sixths and the halves. So not every point is on here. But that would be one of our points. But I don't really like that one because that one's not so easy to graph. So if you look below, and some reason all the fraction bars are in there for cosine, notice we will have all of our special angles here, and we could graph all of those. But look at some of them aren't very nice to graph. Square root of 3's over 2's and square root of 2's over 2's. So we limit ourselves to those x-intercepts and maximum, well, let me start off, maximums and x-intercepts and minimums and x-intercepts and maximums that are actually easy to graph. And let's connect our points, the ones that we did graph, and we will have the graph of cosine. Now this is just, oops, kind of missed my point there. This is just one period of the graph, but it'll keep doing the same things over and over and over again. So in the next lesson, we're going to look at graphing with period changes, amplitude changes, phase shifts, and vertical shifts. So thanks for letting me go through where these values come from for the graph of sine x and cosine x. See you in the next podcast. Bye for now.